For number 44, the only thing they're really checking is that you know that according to the definition of a function, every x value can only have one y value. So for example, if you plugged in 3 for x, you couldn't get both 5 and 9. So the reverse is okay. For example, you can have two different x values that map to the same y value. So for y equals x squared, for example, both 2 and -2 map to +4, and that's totally okay. It fits into the definition of a function. So we're just going to run through these and see, because it's basically just asking, is this a function, and which of these gives the best reason, if so. And so we notice on our map, we're going to look to see if we have two different x values in the x column, which we do. And one of them is mapping to 6, and one of them is mapping to 4. So we already know this is not and cannot be a function. But we're just going to roll through the answers and see what we have that we can eliminate. F says it is, which we know it's not, because the y value is always greater than the x value, and that doesn't even pertain to the definition of function. It is because there are 5 distinct values in both the domain and the range. Well, there are 5 distinct values, but they would all need to essentially be distinct in the x column for this to be true. So, and we already know it's not a function anyway. So this is not the correct answer. It is not, because there are 2 different y values paired with the x value 3. So that is our winner chicken dinner. J, it is not, because there are 2 different x values paired with the y value 5. So that's totally okay. It's totally okay to have 2 different x values paired with a y value, as we discussed earlier. K, it is not, because no equation can be written to model this relationship between x and y. Maybe, maybe not, but that's just a crazy answer to make you doubt your answer. We know that is answer H.